Okay, so here we are told that provided a proper definition for the zeroth law of thermodynamics, then explain in brief two mechanisms of heat transfer. So here, according to this question, the zeroth law of thermodynamics, okay? So who can define? I think you have done this in thermodynamics already. So unfortunately, you cannot find this in the thermal engineering lecture notes. So I don't know why they brought this in the final exams. So maybe they expect you to know. Right? And so let's define it. Zeroth law. So then, now pay attention, please. If, let's say we have two bodies that are separated by thermal insulation material. So this is insulation. Insulation. It's an insulation material, and we have material A, we have material B, material C. So this is A, B. So stop making noise like that. Okay? Be very careful. We are not here to joke. If you are giving a suggestion, give a sensible one, please. So I don't like those students to stay at the back talking rubbish things like this. This is not good. You should discipline yourself. If you want to give a suggestion, give a logical one. Okay? So I have a system A and B. System A initially is 100 degrees Celsius. This is 80 degrees Celsius. So if you put an insulation material over here, this is going to resist the heat flow from A to B. So as far as thermal equilibrium is concerned, there is no way by which energy can be transported from a high temperature to low temperature because of this insulation material. It is going to resist the heat flow. Okay. Now, if I connect these to another material, okay, let's say B, through a conductor. So I'll say this is a conductor. Conductor means aluminum material. This is a conductor. And the temperature of this C is about, let's say, 40 degrees Celsius. So what is going to happen to this object? There will be energy flowing from 100 to 40. There will be heat flowing or energy transported from 80 again to 40. So thermal energy will be transported in this direction. If you give them sufficient time to know each other, it will reach what we call a thermal equilibrium. Thermal equilibrium. Okay, and at thermal equilibrium, they will have a uniform temperature. So let's say this is our system A. This is A, B. Again, this is C. This is C. We will give a uniform temperature. You see, this temperature is going to increase. This will decrease, this will decrease. So eventually, we will assume that all of this is going to have a uniform temperature like this, 60 degrees Celsius. Okay, this gives rise to the definition for zeroth law. The zeroth law of thermodynamics says that if system A is in thermal equilibrium with system C, system B is in thermal equilibrium with system C, then A and B are in thermal equilibrium with each other. That's the classical definition. The definition of thermal, the zeroth law of thermodynamics, it gives rise to the concept of temperature. Yes, any question? Yes. Any question? 6 what? Yes, so because I'm assuming that, you mean why is it 60-60? Yes, because initially when this was not there, I put insulation material here. So heat cannot flow from A to B. But immediately I put a conductor. Conductor means maybe aluminum. I join it to C. So then it means there will be an opportunity where energy will flow from A to C. Because energy flow from high temperature to lower temperature. Similarly, it is going to flow from high temperature to lower temperature. Means this temperature is going to reduce. This temperature is going to reduce, and this temperature is going to increase. So we are assuming that at thermal equilibrium, they will have a uniform temperature. So that's why I get 60-60-60. It could be 70-70-70, but it cannot be 80-80-80. Because of what? Was this 80 degrees Celsius. It cannot be 90-90-90. Because this cannot increase. You understand? So we give a very logical one. Okay, so a uniform temperature. And at this uniform temperature, we say that the system is in thermal equilibrium. So if somebody asks you, what is thermal equilibrium? Thermal equilibrium is the property of a system, okay, whose temperature remains the same or it remains constant. That's a uniform temperature. You understand? So the zeroth law of thermodynamics is telling us that if you have two systems, A and B, and A is in thermal equilibrium with C, B is in thermal equilibrium with C, then A and B are in thermal equilibrium with each other. Okay? So that's the concept. And why, how, what is the benefit, what is the significance of this definition? What is the useful of this definition? It is simple, telling us that temperature is a property of a system. So when a system is in thermal equilibrium, then the temperature of the system remains constant. It does not change with respect to time. It remains constant. It remains uniformly constant. It gives rise to the definition of temperature. Temperature is a thermodynamic property that when a system is in thermal equilibrium, the temperature remains constant in this way. So that's the concept over here. Okay, so by this, we will say that the zeroth law of thermodynamics states that if system A is in thermal equilibrium with system C, okay, and system B in thermal equilibrium with system C, then both system A and B are what? Are in thermal equilibrium with what? With each other. Okay. So you can define it in your own way. The moment you sketch, you can define it anyhow you like. Okay? But again, so I will not go more into details related to this. Let's move on. Then it says, explain in briefly the two mechanisms of what? Heat transfer. So there are three main mechanisms of heat transfer. What are they?
Conduction, convection, radiation.
Very good. Conduction, convection, and radiation spontaneously. So you tell like that. Very good, very good. Practically you see. So but again, you have to go ahead and explain or briefly explain what these two modes of heat transfer are concerned with. So can I delete this back now?
Yeah, you can.
Okay. Okay, so we have conduction, convection, and radiation. So it says only two, so you can tell either conduction and convection only, or any of the two. Just select any two. Okay, then explain briefly. And whenever you are asked to explain briefly, try to give the classical definition, and then if possible, write the equation down and give all the definition. Get marks for that. Okay? So conduction is the mode of heat transfer. Okay? Between high energetic particles of a fluid and lower energetic particles of a system.